Hello everyone, welcome back to Advent of Code Day 5, 2020. We're doing it in Haskell, as always. Oh, maybe this is like this looks like a road or a pier or something that's crooked. I don't know. Anyway, maybe this is an island we're drawing, because we're going to visit an island, and that's it kind of vanishing into the horizon. This is the airport with a runway? Anyway, doesn't matter. We're not actually going to look immediately at day 5. I wanted to revisit something in day 4 first. A change that I made overnight. Which is that, remember I spent like quite a bit of time struggling with operator precedence for applicative stuff because I never quite know how it's going to work. And the answer is that I should just like stop trying to be macho and do it by hand and use applicative do, which uses a very friendly user-facing syntax and translates it to the applicative soup that we were trying to write. You write, language applicative do at the top of your function, your file, or you pass it when you invoke GHC, whatever. And it lets you write do notation, which we're familiar with for monads, but interpret it as applicatives. Now, applicative is less powerful than monad, and so there are things you can write with a monadic do notation that you cannot write with an applicative do notation. Most importantly, we have to end with a call to pure, and none of the values that we define via binding can be used anywhere except in this pure, because that would create dependencies between steps, which applicatives do not allow. Or dependencies between the value inside of the context and the structure of the context, which is allowed with monad but not with applicative. I don't know what it does if you try to use applicative do in a context where a monad is required. It gives you, I assume, some kind of build error, but I don't know exactly what it is. But now, look how much easier it is. We don't have to write like all these weird operators and arrows pointing at the stuff that matters. We just declare a sequence of 6 things. Actually, I can now go just look at the source file. The diff is not important anymore. We just declare 6 things. They're like the 6 kind of, not tokens, but 6 sections of our regex. First, we ignore some white space. Then we match some non-colon characters and store that as a label. We throw away a colon, we match some non-white space characters and store that as a value. We ignore more white space, and then we return a tuple of the label and the value. Very, very straightforward. So I've amended my project template to put applicative do at the top of every file so that I won't have this problem again. Now, it must be said that I don't think applicative do is the right answer every time. For example, here, I think this is great, right? We could be a little bit more... We could do this without repeating the int part if we refactored a bit, but it would actually, I think, not be more clear, so I'm not going to. Maybe we could do this, though. Sure. Align. I'm not generally a fan of aligning stuff, but sometimes I think it's nice. And here it calls out the symmetry a bit more clearly. Anyway, okay, back to here. Day 5. Binary boarding. You board your plane only to discover a new problem. You drop your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people who suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, which is your puzzle input. Perhaps you can find your seat through process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. Oh, exciting. A seat might be specified like front, back, back, front, right, left, right. Okay. The first 7 characters will all be front or back. These specify one of the 128 rows on the plane. Each letter tells you which half of a region it's in. Okay. Start with the whole list, indicates whether it's in front, which is a low number, or back, a high number. Makes sense, it's like an airplane aisle, and so on. Yeah, get it? The last three characters will be either L or R, one of the 8 columns of seats numbered 0 through 7 in the same way. Decoding this reveals it is the seat at row. Okay. What is the highest ID on a boarding pass? Okay, so we just need a function that decodes boarding passes. Sure. I don't know. Is there a good reason to use a regex here? I mean, not exactly. Yeah, we can just split it into chunks of 7 and 3, and then write a function that scans, or I guess probably just folds over. Yeah. We would want a fold R. Yeah. Fold L. Okay. Anyway, let's get started here. Stack new DAO5 AOC. Oops. Actually, it tab completed fine. I sort of thought AOC is the correct way to do it, but tab completion happened to work and it specified the file. That's kind of interesting. Anyway, I don't know what I did. Put it back to the way it was in the file. So we want day 5, source, and indeed applicative do and lambda case are here. Very nice. That's right. I put them both in the template since I was editing it anyway. I guess this is probably the right style. That's interesting. It knows this is an unused language pragma, but it doesn't know this is. Whatever. So we kind of need, while our input is really just a string. No, it's a list of strings. We get, yeah, we get a bunch of these. Okay. And I would not be at all surprised to find that the way we're supposed to interpret boarding passes changes in part 2. So I'm just going to have our input be the string and not like some parsed representation of it. But we do want probably a data of seat is a seat of row. What do we call the seats? If you were in like 25C, you'd be in row 25, seat C, I guess, right? We'll derive show, why not? The highest seat ID. Multiply the row by 8, then add the column, sure. Oh, that's funny. To compute a seat ID, you don't actually need to do anything interesting. Sorry, let me, to compute a seat ID, it is multiply the row by 8 and then add the column, but that's kind of the same as just processing the entire thing as a single 10-digit number, treating, like, I'm not sure exactly which two numbers, but treating like B and L as 0 and F and R as 1, or maybe the other way around, I don't know. Right? I guess F and L are 0. Huh. So we could actually do without splitting things up properly. But I suspect that I will need to know these things, right? So I might as well parse it to an actual seat and then do what they say I'm supposed to do, multiply by 8 and add. Well, you know, we could have it be a tuple of strings, splitting it up into the first half and the second half. Sure. Does Haskell have... It's probably in data split, right? Haskell data split, split at or something. That's what it's called in Clojure. I just want to take some and then drop some, you know? Chunks of split places. Okay, so we could use that. It seems a little bit more powerful than we need. But I think all the other stuff is even more insane. We'll just use I already forgot what the function is called. Split places, right? Yeah, we'll split it into places of 3 and 7. So we have to add that into our Cabal file to get split. And I guess we might as well, we should stack build at this point to make sure we get our dependencies properly. Split places of 7 and 3. This is getting back a list, which kind of sucks. It's a really Haskell split list at index. Oh, it's in Prelude. It's not in split at all, and it's called split at. Oh, don't I have egg on my face now? I just want 7, right? Well, let's get rid of this then. And if we say split at 7 of FF, LLL, we indeed get exactly what I wanted. Okay. I'm so used to all the splitting stuff in Haskell like not being in the prelude for some reason. I have to get split every time I want to split something. We have stuff like span and break, and that's fine, but anything fancier doesn't seem to be there usually. All right, so we can write that, and our input is a pair of strings. That's fine, and the last is we want an int eventually. And so we need a function that you know, like we kind of just want as binary is a function that takes an a to bool and a list of a's and gives you back an int, I think. I think I'll just do this myself recursively. Now, is that dumb? Because the least significant digit is first. Sorry, the most significant digit is first. So, yeah, this is fine. I just, I apply the one function. I apply the one function, and then 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 I apply the one function to the first thing, and then double the result that I have so far. Oh, do I need an accumulator? Is that why this is feeling weird? Yeah, because every time I discover another character, okay, as binary equals 1 equals go of 0, I guess. Equals 2 times what I have so far, 2n plus bool 0, 1. Oh, these should be go, of course. There we go. I should honestly like take the stupid bool 1 thing and make it. Oh, I can just, yeah, digit equals bool 0, 1. I need to import data bool. Okay. The idea here is we call the 1 function on a digit, and then we use bool, which is kind of a way to treat if as a function. You pass it first what you should do if it's false, then what you should do if it's true, and then you pass it a boolean. So if I compose it with this function for creating booleans, I'll get a 0 if the function returns false, and a 1 if the function returns true. Digit of x, and then we go, oh, whoops, I don't add all these together. Go of this and x's, right? What are you mad about here? Use foldl. I told you it was a foldl. All right, I'll take it. Okay, but let's first test that it's correct before I simplify it. And let's say as binary of id, and 1 0 0 1 0 1 0. So this should be what, 10? Oh, not id, equal 1, and it's 10. Cool. So that seems right. I guess I'll just do this. Yeah, I guess I thought at first, oh, this should be 0? I thought at first that I was going to do recursion in some other way, and it didn't make sense to fold, and then I realized I need an accumulator anyway, and that, of course, should signal to me that I need that foldl would actually be fine. So part 1 is maximum of map as binary of lm. So what are the ones again? How do we go to the upper half? R and B? Why? We have, oh, because I actually split it. Oh, right. Well, all right. Let's not do that then. We'll do this part later. Okay. Oh, sorry. You guys can't see. I just said here maximum map as binary, saying treat B's and R's as ones and read me the whole thing. And I guess we should check if we were to run part one of, say, one of the examples from the text, 357, completely wrong. Wrong by a billion. The right answer is supposed to be 44. Okay. What? That's wrong in more ways than I expected. How did as binary work at all? Okay. One zero one is 5. 0 1 0. Like that should be 2, right? Like it looks totally correct. Hang on, how large could the possible seed IDs be? Oh yeah, they could be large enough. We have 10 digits, so they could go up to 1,000. Okay, so it's not like I must just have the numbering wrong. The last 3 characters, the seed ID. Back and right. Okay. Well, you know what we can do? We can temporarily remove the type signature. The program will like no longer compile because I'm going to change what it does. We'll scan L and just remove these as well. And now I want to see. Did the rest of it even parse? Can I as binary? No, the whole file has to be valid. Kind of annoying. All right, we'll just put an identity there. And then if we say as binary with lm of B and R, and then the string we were using, which is this, it should tell us how it was doing. Started with 0, that makes sense. Oh, wait a minute. I just was misreading the example here. I just like saw 44 and was like, that's the answer. But no, there's this 5 here still. So this should have a seed ID of 357, which is exactly what we have. And okay, there was no debugging left to do. It was correct to begin with. And we just need to change this back to full del. All right. Stack run? No, stack gets run. The annoying thing is that stack run is like actually slower than just like, because it compiles. It's slower than just stack run GHC of the input file, but then you have to type more letters to say what the file should be. I don't know. So let's try it out. 813 is our highest seed ID. That's the right answer. Great. Well, let's get committed. Day 5, Part 1. And I assume in Part 2 we'll have to know about rows and columns, finally. Ding! The fasten seatbelt signs have turned on. Time to find your seat. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in the list. What's the ID of your seat? Oh, so we didn't need to separate this whole seat thing at all. Oh, actually I didn't end up using seat. So let's pretend we never wrote that. Okay. Well, so we just have to find the we just want to sort it, right? And find the lowest one. Sort it and then zip it into pairs and find the only pair whose delta is, well, there'll be 2 pairs, I guess, no. There'll be a gap. If we only look at the seat IDs that are present, there'll be a gap between 2 other seats. And that'll have a delta of 2 instead of 1, and ours will be in between that. That's so easy. Okay. So we'll change our input then to be a list of int, I guess. And do this thing here. And so all we need to do is I guess we're outputting a maybe int because in principle our answer might not be there. We need to do a few things to this. First, we sort it. Sort is in, okay, it's in the prelude, so I don't have to import it. And then we zip with tail, which gives a list of pairs. Zip, this is like, I don't know, this is needlessly cute, but it is kind of nice. When the applicative that you're using is functions of one argument, this operator means to call both things with that argument and then call the results. We get zip x with tail x is what this function does. It's a function of x that calls zip x with tail x, giving us pairs. And then I guess we're eventually going to want list to maybe, and we also want filter. Oh, we can actually just return a list of int instead, a list of all gaps. We want to filter that x, y, that y minus x equals 2. And finally, we want to map the 1 plus the first item in the tuple. All right, so I got something wrong. Oh. Sort is not imported from, it's in data list, I guess. Okay, it type checks. I mean, how wrong could it be? So all the seats that are in a gap of exactly 2 are exactly 612. That's simple enough. That's the right answer. Huh. They usually, I thought, make the problems somewhat more difficult on weekends because people have more time. And also, like, this one just had this complete red herring of the column versus the row versus the seat number, right? It didn't matter at all. All we cared about was the seat ID. That's a little annoying. Okay, well, I mean, I guess we're done, right? Day 5, part 2. And if we get show, it should be like pretty simple, right? We added sort, we moved our reading of seat IDs into the prepare step, and then we wrote this cute little filter and sort thing. I wonder if I should amend my template to remove the I parameter from part 1 and part 2, because I very much prefer to write them as a composition of functions where possible. And I guess I sort of thought it wouldn't be possible that often, but I guess it is. So, you know what? Let's do that now. Oh, I see. I have to change this anyway. Well, at least then I can just delete the whole right side, yeah? Anything else I should mess with? Yeah, I should put a new line here. What are all these warnings I have? Okay, whatever. 2020, I guess? Looks good. No. Update template. That's fine. Okay, cool. Well, hope you guys enjoyed. Thanks for watching, and I'll see you next time.